Alright, in the previous lecture, we had looked at the various things that Galileo was seeing through his telescope, such as the phases of Venus, which showed that Venus was going around the Sun. He saw planets going around Jupiter, which showed that they can go around not even just the Sun, but they can go around other planets. So that makes Earth even less special, that there are so many different bodies in the universe that things go around. He saw the individual stars making up the Milky Way, which had a big role to play in making it apparent that the stars were not all equidistance away. So in order to have no observable parallax, we need the stars to be really, really far away. And his observations mesh with the idea that they are really far away. He also saw sunspots on the Sun and mountains on the Moon, which kind of indicated that they weren't quite as perfect as we might have thought. And one thing we have to bear in mind is that Galileo was in a different environment than Kepler was, even though they were contemporaries. They passed letters back and forth, that type of a thing. Kepler was in Germany, which at the time wasn't quite as under the influence of the Roman Catholic Church as Italy was. The church was very strong in Spain and in Italy. So Galileo had to contend with some different issues than Kepler did, which is why he was originally quiet about the whole Copernican idea being the way to go. But once he got enough information, he couldn't really keep his mouth shut anymore. He had to tell people what he was seeing through his telescope. So the initial religious response was that the devil had possessed his telescope. There's his telescope, and there's, yep, that's the what they thought was happening. And as a consequence of this, obviously it was very dangerous. Looking through his telescope would have imperiled their souls, so they refused to look. Many scholars did. And another thing to bear in mind is that many scholars at the time were associated with the church. So this was a very scary proposition for them. And there's the scholar. One thing I don't quite understand about my animation is that he could have run off the screen to the left, but instead he ran to the right. Doesn't quite make sense to me, but that's what they did. They refused to look. So if you can imagine Galileo, who was himself a religious person, but he was also open to observation, informing his reality, this was extraordinarily frustrating. All he wanted was to be able to tell people about what he was seeing, things that nobody else in the world had ever seen before. And he wanted them to look, and they wouldn't. So it wasn't that he was wrong, or that his data wasn't correct, or that he wasn't interpreting it correctly. It's that nobody would listen to it or look at what he was seeing. Nobody would confirm that he was seeing what was actually out there. So extraordinarily frustrating. In addition to that, so he had stayed quiet, and actually I'm going to shift. There we go. It was cutting off a little bit. So for many years, as I said, Galileo stayed quiet. Prior to 1616, the Inquisition had ruled that the Copernican model was a mathematical theory and nothing more. What this allowed people to do, like Galileo, was actually talk about the Copernican model. Talk about the idea that the Sun was in the center of the universe, not the Earth. Because the Inquisition had kind of decided that they believed Copernicus when he said, look, I'm just trying to make up something mathematical, see how it works, see if we can make it mathematically easier to deal with. The problem was that after a while, people like Galileo were talking about it, and it was obvious that they weren't talking about it as just a model. They were talking about it as a possible reality. And so they condemned it. Galileo was sent a nice letter telling him not to talk about the Copernican view anymore as a possible reality. So Galileo, who had experienced maybe a 5-year, 6-year span of really actively promoting the Copernican model, was told to be quiet about it now. And he did. He stayed quiet. Until a new pope came into power, Pope Urban VIII. A friend might be too strong of a word here, but he and Galileo knew each other. They had had conversations, and even after Urban VIII became pope, they had conversations. And they had conversations specifically about the idea of the Earth in the center of the universe versus the Sun in the center of the universe. And so Galileo, he knew the Pope. He felt like they had talked about the idea of the Copernican model versus the Ptolemaic model and so on. That he realized, well, maybe now there's an opening, even though it's been officially condemned. I've talked about the Pope with it. It should be okay. So he started talking about his views again, and he actually wrote a book called The Dialogue. Dialogue, it's normally just called The Dialogue, but the full name was Dialogue Concerning the Two Chief Systems of the World, Ptolemaic and Copernican. And first of all, this was a little bit disingenuous because the Tychonic model had, for many people, supplanted the Ptolemaic as the way to go. However, it was easier to fry the Ptolemaic model compared to the Copernican model than the Tychonic model compared to the Copernican model, particularly with the observations that Galileo had made. It's also important to understand that Galileo did not like Kepler's claim that the orbits of the planets were ellipses. He still felt that they must be circles. So this was one point where Kepler and Galileo disagreed, and it's one point where, in spite of Galileo's fantastic observations through the telescope, he was still being held captive by these old ideas, in spite of the evidence. So just more, I think, more evidence showing how amazing Kepler's discovery of the elliptical orbits was. Anyway, this book that he wrote featured two people, two chief characters, Salviati and Simplicio. Salviati, as the name sort of sounds like, means somebody who's sophisticated, intelligent. Simplicio, not so much. And in it, Salviati was arguing the Copernican view. Simplicio was arguing quite ineffectively the Ptolemaic view. But Galileo did want to do this right, even though he wasn't terribly afraid of getting into trouble. He wanted to get permission from the church before he published any of his results. He was based in Florence, so he submitted it both to Florence and to Rome. And in Florence he got permission, but Rome actually never gave permission. However, Galileo wasn't the most patient of people, so he published the book. However, he made a big mistake. He had Simplicio say some things that the Pope had once said to Galileo. The Pope did not particularly like the idea of being made to look like an idiot. So Galileo was tried and was found guilty. And after Galileo protested that he really hadn't meant anything by it, he hadn't meant anything by the idea that, you know, the planets are going around the sun. He just meant it as a mathematical theory, which was sort of the safe haven prior to 1616. They still found him guilty and sentenced him to house arrest, and they forbade him from ever researching basically planetary motion again. So Galileo went back to some things that he had done previously. And prior to his whole sort of affair with the telescope, he had been studying relative motion and freefall. And what he did now was he was able to determine that two objects with the same motion see each other at rest. So he was able, he was the person who came up with the mathematical construct of relative motion for objects, which was a big deal. And so basically what this meant was that a body dropped from a tower will have the same velocity as the tower parallel to the Earth, and thus it will not fall behind the tower. The same thing would be true of the birds and the trees, of course. So if a bird is in a tree, it's going to have the same velocity as the tree. And so if it launches itself and it can fly with 5 meters per second, it doesn't mean that it can never catch that tree again, which is moving much faster. It's moving at 5 meters per second relative to the tree. So it's able to get onto the tree. And so by proving that birds can exist on a rotating Earth, he also shows that the Earth can rotate. So even though he was told never to work on anything involving the Copernican model again, he kind of did. And he got away with it. He worked on the idea of relative motion, which in a roundabout way shows that the Earth can rotate. Now here comes the final thing, and we'll talk about this in class. So Galileo had basically destroyed the crystalline sphere model, and with it the prime mover, which was the motion behind all sorts of planets and stars. And what this left in its place was questions. How did the planets move? What caused them to move at their varying speeds? Why did they speed up when they were closer to the sun and slow down further away, as Kepler found with his second law? So these were the big questions that were left after Galileo and Kepler kind of left the realm of the studies. And it was left for Newton to finish it up. And we'll talk about Newton and his discoveries in class.